Okay, Assalamualaikum. Hari ni kita nak sambung kita punya discussion. Okay, so hari ni kita sambung dekat definition of electronegativity and explain the variation in electronegativity across period 2 and 3 and also down the group 1 to 13 to 18. Okay, so electronegativity. Okay, so we go for the definition of electronegativity. So electronegativity means by relative tendency of an atom to attract electrons to itself when chemically combined with another atom. So electronegativity is what is the tendency of the atom to attract electron of the other atoms to form a bond with the atoms. Okay, atoms with strong attraction for the bonding electrons are said to have a high electronegativity. Means the higher the electronegativity, the stronger the attraction for the bonding electrons to form. Alright, so the most widely used scale was developed by Linus Pauling. He assigned the most electronegative element, fluorine, a value 4.0 and worked out the others relative to the fluorine. Okay, next we go to the variation of electronegativity across period 2 and 3. So which is the period 2 and 3? So this one is a period 2 and this one is period 3. Okay, so what we can see across period 2 and 3 from left to right periodic table, we can see that the size of atom become smaller. Okay, so across period 2 and 3. Okay, so when the size of atom becomes smaller, okay, the stronger the attraction of the nucleus, because the smaller the size, the stronger will be the attraction from the nucleus. So what happened is so we look at from the definition. Okay, so the tendency of the atom to attract bonding electron to itself increase. Therefore, electronegativity increase. Okay. Okay, so from the okay, so when across period we can see that, alright, the value of electronegativity increase from lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay, but when we going down a group 1 from lithium, sodium, potassium, rubidium and cesium, we can see that electronegativity decreases. So we can conclude that when we across period, okay, electronegativity increase. Okay, but when we're going down a group, electronegativity decrease. Okay, here we can also see the value of electronegativity from sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon when we across period 3 of element. So we can see that the electronegativity also increase. So roughly electronegativity depends on their size. So the smaller the size, the stronger the attraction. So the ability or tendency of the atom to attract electron closer to itself, bonding electron to itself, so the greater the electronegativity. Okay, this is a summary or the main point to explain the electronegativity when we across period. Okay, as we go across a period, proton number increase. So when the proton number increase, effective nuclear charge increase, right? So the atomic size decreases. Therefore, the nucleus attraction towards valence electron becomes stronger because it has a greater effective nuclear charge. Hence, the atom has a greater ability to attract the bonding electron. Therefore, electronegativity increase. But when we going down a group, as we go down a group, number of shell increase. Shell means principal quantum number or number of energy level. So it cause atomic size increases. Therefore, the nucleus attraction towards valence electron becomes weaker. Therefore, it has greater shielding effect. Hence, the atom has less ability to attract the bonding electrons. Therefore, electronegativity decreases.